get started. Are there questions over 7.1's homework on our inverse and direct? Yes. Now what we're talking about today, we're going to start off with simplifying rational expressions. And we can say a fraction, this rational expression, is simplified when it has no common factors other than positive or negative 1. So if what's on top and bottom is only factors left are positive 1 or negative 1, then it is simplified. Anything else that's in common, we need to reduce out. So like with this here, we have AC over BC. Since C is in common on top and bottom, we simplified out, leaving us with A over B. Same thing's true with numbers, 15 over 65. 15 and 65 have a common factor of 5. We would reduce the 5 out, leaving us with 3 over 13. Same thing's true with expressions. Because if we look at this first example here that they gave us, top has x plus 3, the bottom has x plus 3. Since it's in common on top and bottom, it would reduce out. It becomes 1, leaving us 4 over x plus 3. We're dividing those common factors out. We're removing those common factors out. So if we look at this first example here, 4 over x times x plus 2. What is in common on top and bottom? There isn't anything. Because we might say the 4 and the 2, but because of addition and subtraction with that x plus 2, it's one term, it's one expression. We can't think of the x and 2 for that x plus 2 to be two separate things. It is stuck together. Multiplication, we can split them apart, we can move things around and simplify that way. But with addition and subtraction, they're more locked together. That x plus 2 is a term. So this here is, it is simplified. That's as simplified as it gets. We can't do anything to it. There's nothing in common on top and bottom. It was simplified from the start. Well, let's look at the next one. On top, we have 2 times x plus 1. On bottom, we have x plus 1 times x plus 3. Now, there is an x plus 1 in common on top and bottom. And we can simplify it out. What's left on top? What's left on bottom? That's simplified. Yeah. The only thing we can make this quote-unquote harder is adding in factoring. That's also why we spent the first part of the semester going back over factoring, because it's essential for this year. Now, I will bring this, or kind of note this out, because when we multiply, we'll talk about this here, when we multiply two rational expressions, we multiply numerator with numerator, top with top. But we can also split it back apart. So 2 times the quantity x plus 1, 2 times x plus 1, is the same as having 2 on top of one numerator, x plus 1 on the other. Do we agree with that? Yeah, on bottom, we can do the same thing with the x plus 3 and x plus 1. Now, the reason I write it this way is, well, 2 over x plus 3 is our answer, yes? Over here, x plus 1 divided by x plus 1. Anything divided by itself is 1, yes? So really, x plus 1 divided by x plus 1 is just, that's why that simplifies. That's why it simplifies with multiplication. We can't do the same thing with addition, subtraction. So it's just 2 over x plus 3 times 1, which is just our 2 over x plus 3. Questions on this here? Restrictions. Because with fractions, we can't divide by what? What's the one number we cannot divide by? 0. We can't divide by 0. Funny enough, dividing by 0, what we get from trying to do that is a little more complicated than that. Yeah. If we have time, I can delve a little bit into it. It's kind of interesting. X plus 1 and x plus 3, these are the two spots where we could have a division of 0. So x plus 1 cannot be 0, and x plus 3 cannot be 0. Because if x plus 1 becomes 0, the whole denominator, the whole bottom of this fraction becomes 0. If x plus 3 is 0 for that value of x, the whole bottom of the fraction becomes 0. So what we can do to figure out what's going to make this 0 is, well, set them equal to 0 and then solve them individually. So if x is negative 1, our x plus 1 would become 0. So what we can say is that x is not negative 1, and we restrict it. It's a restriction. With x plus 3, we would do the same thing. Solve it by subtracting 3, telling us that if x is negative 3, the denominator would become 0. X can't be negative 1 or negative 3. If we have either one of those, we have a division of 0. It doesn't work. Does that make sense? Now, depending on the textbook, depending on the teacher, some will say that we don't need both of these. Some say that we do. And the one that they would say that we would need, for sure, is x is not equal to negative 1. Because, where did that come from? It came from the x plus 1, but it factored out. So we have to list it because that term, where we get that restriction from, is now gone. We have to list it as a reminder. They say we don't have to list the x minus 3. X is not equal to negative 3 because what? It's still in the bottom of the expression. It's still there as a reminder it doesn't work. If we're listing the restrictions, personally, I'm like, might as well go on and list them both. No reason not to. They're both there. Those are our restrictions. Does that make sense? Okay. Let's look at the next one. Are these factored? So it is tempting to cross out the x squared and x squared. And we could if the x squared and negative 4 on bottom were being multiplied. Here, they're being subtracted. So we can't just cross out, go x squared, and be done. Because on top we have x squared minus 4x minus 12. That is one term. They're all stuck together. On bottom, x squared minus 4, those are stuck together. So we have to factor. Now with factoring these here, I always start on whichever one I think is going to be easier to factor. So when you're looking at these, it might be different, but whichever one you can see the factors of first, I would start with it. Personally, I like the x squared minus 4 on bottom a little bit nicer. Now there isn't a greatest common factor between x squared and 4, but it is what? A difference of perfect squares. Because what times itself is x squared? And what times itself is 4? And our signs are opposite. Because our difference of perfect squares are nice. X squared minus 4 is x plus 2 and x minus 2. Because it's our a squared minus b squared is equal to a plus b times a minus b. And I think it'll be helpful for y'all to go with whichever one you can see the factors at first. Factor it. Because when we go to factor the other one, the numerator, x squared 4x12, is there a common factor between these three? No. Okay, so we'll do our two sets of parentheses. Now, if something's going to factor, one of these numerators has to match with one of the denominators, yes? Which means one of those sets of parentheses on top has to be what? Either x plus 2 or x minus 2. Because if one of them's x plus 2, the x plus 2 and x plus 2 would cancel, yes? If one of them's x minus 2, those would cancel, yes? So the denominator factoring it first gave us a hint at what the numerator is going to be. Y'all see how that works. Now let's see how this helps. So x squared minus 4x minus 12. The third term is negative, so the signs are opposite. One's going to be positive, one's going to be negative. Our factors of x squared are x and x. Factors of 12, 1 and 12. So these are all the factors of 12. Which of these factors would we want to try first? 2 and 6. Because if we tried 3 and 4, we wouldn't get any common factors no matter the sign. Because if we do 3 and 4, no matter how I set the signs, they're not going to match up with x plus 2 or x minus 2. I need, in one of those two spots, to have 2 to give us our factor. Do we want the 2 positive or negative? 6 negative. And again, we can check and make sure. X times negative 6 is negative 6x. Positive 2 times x is positive 2x, giving us negative 4x. That is the middle term we wanted. Now, is there something in common on top and bottom? And it would be x plus 2 and x plus 2, leaving us with x minus 6 over, and since the only thing now left in common is positive or negative 1, that is factored. Restrictions. For the most part, I'm not going to be looking for it on the homework, but it is going to be helpful, especially when we get to solving. Because when we solve this here, our restrictions tell us what x cannot be. X cannot be these values. So when we start solving, if this was one of the equations we're solving, we find the restrictions first. X cannot be negative 2. So if negative 2 shows up as a solution, we know it's not going to work because we'd have a division of 0. We can throw it out. Add 2 to both sides. So it's telling us x cannot be 2. So if 2 or negative 2 shows up as a solution, it's a restriction. It's an extraneous solution. It doesn't work. If it ends up being that all of our solutions are restrictions, it's no solution. Questions on this here? Are we ready for the next one? X squared minus x minus 12 over x squared minus 9. Finished? Thank you. Which one do we want to factor first? X squared minus x minus 12 or x squared minus 9? Okay, x squared minus 9, we'll factor it first.
X plus 3, x minus 2.
Because that's, again, our difference of perfect squares. And it's helpful because it is telling us that one of the numerators is going to either be x plus 3 or x minus 3. Because if it's not either one of those, it doesn't simplify. It's as simplified as it gets. Now our third term is negative, so our signs are opposite. Factors of x squared. X and x. Factors of 12. 1 and 12. 3 and 4. Okay. 3. I would agree, because if something's simplifying, it's going to have to be 3, 4. Do we want the 3 to be positive or negative?
Yes. The 3's negative.
4 is positive. So let's just check it to make sure. X times negative 3 is negative 3x. 4 times x is going to be positive 4x. And negative 3x plus 4x is positive x. So it's correct number but wrong sign. So we need to flip the signs. Is there something in common on top and bottom? Would be. So x plus 3 on top and bottom would cancel, leaving us what on top? 4 over. Now you don't have to write restrictions every time. We're just going to say that x cannot be these values. Now the two places where we could have a 0 is x plus 3 and x minus 3. Now with x plus 3 we would minus 3 from both sides, telling us x cannot be negative 3. Here we would add 3 to both sides, telling us x cannot be 3. So here, if x is positive 3 or negative 3, we'd have a division of 0. It doesn't work. Questions on this here? I mean, the only way that we can make this quote-unquote harder is just putting in different sets of factorization. Yeah. So the numerator x plus 4, the degree is 1, because the only variable we have on top is x, and its degree is 1. So we can't factor it with our normal sets of parentheses. The only way we could factor something like that looks similar to x plus 4 is if it has a greatest common factor. Something goes into both terms, which there's not. So x plus 4 is as simplified as it gets. Now, if we look at the denominator, x squared minus 16. Okay. Now is there x plus 4 and x plus 4 are in common. So what's left on bottom? X minus 4. What's left on top? So it's simplified out, yes? So what would we write? It is not. Because when anything's simplified out, x plus 4 divided by x plus 4 is what? 1. Anything divided by itself is 1. So if it simplifies out completely, it's going to reduce to 1. The only way it would have become 0, or only way we can get 0 on top, or a 0, is that we multiply by a 0 or add or subtract from the reciprocant. But when we simplify something out, we're dividing it out. It's going to reduce to 1. When we simplify out, it's going to reduce to 1. So our restrictions. Yes. Because so with x plus 4, we would subtract 4, telling us x cannot be negative 4. With our x minus 4, we would add 4, telling us x cannot be 4. And that's it there. Questions on this here? We ready for the next one? X squared minus 2x minus 3 over x squared minus x minus 6. There's no greatest common factor on top and bottom in either one of the expressions, so we're going to need to factor. Now we don't have a sum or we don't have a difference of 2 squares, so we just got to pick one, top or bottom. Bottom, x squared minus x minus 6. We'll factor it first. Now, as we already said, there is no greatest common factor between these three terms. So we'll move to our two sets of parentheses with three spaces. So we will have x and x. Our signs are going to be plus and minus because the third term is negative. Factors of 6 are 1 and 6 or 2 and 3. Which one do you, out of the 2 and 3, which one do you want positive, which one negative? So is the middle term positive or negative? So let's check it. X times negative 3 would be negative 3x. 2 times x would be positive 2x, giving us a negative x. That is the middle term we want. All right, let's factor the top. And again, x squared 2x 3, no greatest common factor. Third term is, so the signs are opposite. Factors of x squared. X and x. Factors of the third term, 3. 1 and 3, yes? So, we need the, so the only factors of 3, I'm going to write them down. 1 and 3, yes? If with the 1, is there any way to get something in common on top and bottom? If I put it with the plus or minus. What is the one thing we could have in common? Was with the 3, yes? And what's the one on bottom? Our factor is x. Because if I put the 3 with the minus, we do get x minus 3 on top and bottom, yes? Okay, let's say I put it with the plus. If we have x plus 3 on top and 1, okay, there's nothing in common on top and bottom for this to factor to simplify, yes? Now, even though this does give us a common factor, on top and bottom we can simplify, we still need to check, just to make sure. X times negative 3 would be negative 3x. 1 times x is positive x, so plus x. Negative 3x plus x is the negative 2x we want. So there is something in common on top and bottom, and it's x minus 3. So we can cancel that out, leaving us with x plus 1 over I don't think so. X plus 2, yes. Because again, we cannot have a division of 0. And for these expressions, if the bottom of the fraction becomes 0, it's what gives us that division of 0. And really, a fraction is just another way to say that we have division. The top is being divided by the bottom. So the dividing by 0, anything that would make a division of 0 is what we list for our restrictions. Yes. Yes. Questions on any of this here so far? When we multiply two fractions, we multiply numerator with numerator, denominator with denominator, and then simplify if necessary.
Oh, so if we literally just do each rational expression, like simplify it and then multiply?
Yes. So there's two ways. One, we can do simplification, as you just said, first, and then multiply and then simplify again. The other option is we multiply and then simplify. Both work. Okay, so let's look at simplify and multiply here. So the first thing we're going to look at is the 8x cubed y over 2xy squared. 8 over 2 will reduce 2, because the 8 would reduce to 4, and the 2 would reduce to 1. because 8 over 2 is just 4 over 1. I hold off on writing the 1 until at the very end if it does simplify out completely. Now we'll look at the x's. X cubed over x squared. When we divide like bases, we subtract the exponents. So the exponent on bottom is x squared, because 3 minus 1 is it bigger on top or bottom? Top. So it stays on top. Because really what we're saying, we have x 3 times on top, 1 time on bottom. So one of the ones on bottom simplifies with one of the ones on top. No more on bottom, we have 2 left on top. That's really all we're doing. The next one, we have y to the first over y squared. 2 minus 1. 1. And since it's bigger on bottom, it stays on bottom. Because really we have 1y on top, 2 on bottom. So one of the ones on bottom simplifies with one of the ones on top. The y's on top are gone. We have 1 left on bottom. Now we look at the next rational expression, 7x to the 4th, y to the 3rd over 4y. 7 over 4, is there anything in common that we can reduce? No. 7 stays on top, 4 on bottom. We have x to the 4th on top. Do we have any x's on bottom? Nope, so the x to the 4th stays there. Y to the 3rd over y. 3 minus 1 is 2, and since it's bigger on top, it stays on top. Now we can multiply this out. The denominator 4 times y is 4y. On top, 4 times 7 is 28. We could left it as 4 times 7. We can multiply. Either way works. X squared times x to the 4th. When we multiply like bases, we add the exponents. So 2 plus 4 is 6. 2 plus 4 is 6. So x squared times x to the 4th would be x to the 6th. There's no y in the first one, but there are 2 of them in the second. So it just stays y squared. (24) or 28 over 4? It would be 7, yeah? And it's going to be on top. There are no x's on bottom, so it's just going to stay x to the 6th, yes? Now we do have a y on top and bottom, so y squared over y. Because our 2 minus 1 is 1, and since it's bigger on top, it stays on top, yes? Well, the force, 28 over 4 reduced to 7 over 1. Is there anything left on bottom besides 1? So our final answer is 7x to the 6y. Restrictions. This one is kind of nice. Because what were the only 2 things we had in the bottom? X and y, and they're all being multiplied together, yes? Means x cannot be 0 and y cannot be 0. The only thing they can't be is 0. They can be anything else. They just can't be 0. Questions on this here? Okay. I want to look at this one again because, again, I want to show you the other way to do this. Because we can do the simplify, multiply, simplify. Yes. So I want to show you what would happen if we just straight multiplied everything together and went from there. So on top, we have 8 times 7. 56. X cubed times x to the 4th is going to be x to the 7th. Y times y to the 4th. On bottom, we have 2 times 4. There's only one x in either one, so it's just x. Y squared times y is y to the 3rd. 56 divided by 8, that would simplify to 7 over 1, or 7. X to the 7th over x. because we have 7 minus 1, which would give us x to the 6. And since it's bigger on top, stays on top. Y to the 4th over y, 4 minus 3 is 1. And since it's bigger on top, it stays on top, telling us it's
easier that way.
if it's easier this way, do it this way. Because again, whichever way you do it, I would pick the way that y'all see or understand the best. Because both work, both get us to the answer, it's just figuring out which one we see better. Because we also have, with this here, 2 times 4 is what? 2 times 4 on bottom is what? So we can manipulate it in some ways to simplify that there if we see it. But either way, we get to the same answer. So let's look at this here. On top, we have 6 times 9. 6 times 9 is? Six times 6 is 36. 4 times 9 is 36. 6 times 9 would be 54. X squared times x to the 5th would be x to the 7th. We add those exponents. Y times y squared is going to be y to the 3rd. Yes. 3 times 2 is 6. X, there's only one of them. Y cubed times y would be y to the 4th. So 54 over 6. Well, they both have a common factor of 6. 6. So 54 would reduce to 9 if we remove that, factor it out. And 6 would reduce to 1. Yes. The x to the 7th, we can remove an x from it on top and bottom, giving us x to the 6 on top. The x on bottom would reduce out.
Y to the y on the bottom.
Y to the 3rd over y to the 4th. 4 minus 3 is 1, bigger on bottom. We can remove 3 y's on top and 3 y's on bottom, which leaves us with 1 y on bottom, leaving us with 9x to the 6 y. But again, we don't have any additions or subtractions, so x cannot be 0, y cannot be 0. Questions on this here? So either way, if we simplify first and then multiply, or multiply then simplify, we'll get to the same spot. It's whichever one you find easier to do. Questions on this here? 8 times 9 is 72. Now we're going to